All right, so here is the key to your test review. On 1 through 3, it says state the domain and range for each of the relations. So remember, if it does not say what type of notation to use, we use interval. So interval notation is what we want here. So on number 1, our domain. Domain, we are looking at the x's. Okay, so our x values here. And I don't have any x values until I get here at -4. And then my x's keep going. I can use all these x's all the way out there to infinity. I know there's no arrows here, but you know they're supposed to be to infinity. We never include our infinities. In this case, I do include -4 because there is a point here at -4, an actual value on my graph. So I include it and it's a bracket. The range, okay? Range, I'm looking at my y values. So my smallest y value, since this continues on, it's going to keep going farther and farther down. So I start way down here at -infinity, and I keep going. All these y values will have something on it, and then so will these because that keeps increasing over there. So it's -infinity to infinity. So for the domain of number 2, my x values. Now a couple of things are happening here. I have an asymptote. My asymptote is right here. So as I increase from going from -infinity on my x's, -infinity, okay, so y is increasing, but the x values are getting really, really close to 0, but they never actually make it. So we're going from -infinity to 0. I do not include my -infinity, and my 0 I'm not including because there's an asymptote there, so I'll get really close, but I'll never actually make it. Then I got to start over on the other side. So this has to be a union. Remember, no little tail on there. And I go from 0 to infinity. Okay. Then I also have a horizontal asymptote that's going to affect my range. So my range, I'm starting that way down here at -infinity would be a y value that works, all the way up to, but not including 0. And then I jump on the other side of 0, and it's 0 to infinity. On number 3, my domain, my x's here. So the first time I have anything, there's not even anything out here, right here at -3. All the way to, and I don't know what's going on with this, but this isn't an asymptote or anything, but I'm going to make it dotted so I can make it straighter. For whatever reason, this doesn't show up on my board. So pretend like that's solid. That's not an asymptote. Oh, see. But that is a line on the grid. All right, so from -3 all the way to here, and on these, some lines are darker than the other. I don't know why it happens on the board sometimes and not on your paper, but if it helps you to highlight or, I don't want black, I guess. Highlight the axes so that you can actually see them and that you know where to count from. You can do that. So from -3, and then 1, 2, 3, 4, 5 to 5. I do not include -3 because it's an open circle. So I get really close to -3 but don't actually make it. And then I do include this one because it is a closed circle. Then for my range, no y values down here. The first y value I come to is this one. So that's 1, 2, 3, 4. That is a -4. And then all these y values work up to 0. -4 is a usable y value. 0 is not, so it's open. There is domain and range. Make sure you know when to use the parentheses and when to use the brackets and when to use the union. All right, so now it says evaluate each function for the given value. So we are just substituting this in. Basically, I want h of -6. So first step is for me to substitute it in, -6 cubed minus, oops, so I have to put x, minus -6 squared plus 4 times -6. So -6 cubed is going to be a -216. -6 squared is +36, but that's -36. and then negative 6 and a positive 4 is a negative 24. Now when you combine these, you can combine them in any order and do whatever makes the most sense to you. I'm going to first of all, they're all negative, so yes, I'm subtracting, but really I'm just going to add them all together and keep the negative sign. But I'm going to combine these two together first, because that 6 and the 4 tells me I'm going to get a 10 there. So I'm going to rewrite the negative 216, negative 36 and negative 24. So the 30 and the 20 is 50, the 6 and the 4 is 10, so that's minus 60. Then that's pretty easy. I get negative 276, and that is equal to h of negative 6. And make sure in the end you don't just give me a number, that you actually say what it is there. All right, number 5. F of 4x equals negative 4x squared plus 5 times 4x. That's equal to, I square this, the negative sign has nothing to do with that exponent. So it's going to be a negative whatever, and that's 4x squared. I square the 4 and get 16, square the x and get x squared, plus 5 times 4 is 20x. Now, could I factor this? Yes, I could. I could factor out a GC. It says to evaluate, we substituted it in, we simplified it. I can say this is f of 4x, and I am done. Don't do extra stuff just because you're capable of doing extra stuff. All right, so here it says we're going to identify the x and y intercepts. That word intercepts means they have to be ordered pairs. If it says the roots, solutions, values, whatever, that's when you do the little set notation squiggly brackets. So to identify the x and y intercept, well, there's a 1 here and a 1 here. So my x-intercept is going to be at negative 3, 0. My y-intercept is going to be at 0, 3. All right, so then it says to algebraically find the zeros and the y-intercept of the function. So to find the zeros, that's when you make y equal to 0. So that's going to be 0 equals 2x squared plus 9x minus 5. Then you got to decide what you need to do. Well, we need to solve for x, because the 0 is the x-intercept, which is the x value when y equals 0. So you got some options here, but one option is not to add 5 to both sides. Don't move 5 over here and then start making up math. You want to factor this, okay? So in order to factor this, I'm going to multiply this 2 times negative 5. That gives me a negative 10. So I need the factors of negative 10, which could be 1 and 10, could be 2 and 5, and that's kind of it. And I need those two. The signs are going to be different because it's negative. I need them to give me a positive 9, which means that this is going to be a positive 10 and a negative 1 that I am using. So when I do that, I am now going to do some grouping. 0 equals, I leave that 2x squared like it is. This 9x now gets split up into this. We'll do plus 10x minus x minus 5. So if I added these back together, I would end up right back at the same spot. At any point, you should be able to go backwards and end up back where you were. So now I'm going to factor out the GCF of these two little terms that I'm grouping. So 0 equals, I can factor out a 2x here. That leaves me with x plus 5. If your x term is negative, you want it positive. So you're going to have to factor out a negative something. In this case, it's negative 1. And then this is x plus 5. So now I have two big terms. This is now my GCF in those two terms. I factor that out, and I get x plus 5 times 2x minus 1. So now that I have those two, I set my two little pieces equal to 0. So that means x plus 5 equals 0, and 2x minus 1 equals 0. So x equals negative 5, and x equals 1/2. So it says the zeros. It does not say intercepts. So my zeros are -5 and 1/2. There are my zeros. Now I need to find my y-intercept. So for the y-intercept, I've already made y 0. This time I make x 0. So now I want g of 0, which is equal to 2 times 0 squared plus 9 times 0 minus 5. So that's 0 plus 0 minus 5. So g of 0 equals -5. But that's not my answer, because if it says y-intercept, my y-intercept should be an ordered pair, which is going to be 0, -5. Okay, so number 8 says give the coordinates and classify the critical points for the graph of the function. State the intervals on which each function increases or decreases. So these aren't exactly on grid lines, so we're going to estimate, because we're not going to worry about getting the calculators out for something like this. And like I said in class here, when you estimate, it's either a whole number or it's a 0.5. That's it. Don't even try. It doesn't need to be any more accurate than that. So this x value here, I feel like you could argue it's either a -1 or -0.5. I would take either one. But I'm not taking -1.5 because that's way over here, or 0. I mean, within reason. So your critical points include maximums, minimums, and points of inflection. So this first point right here, this point is at, we'll say it's at -1 and 1, 2, 3, 4, 5, -5. So -1, -5. If you put -0.5, it's totally fine. And that is a minimum, but I can't just put minimum. There's no y values that are less than this one right here. That makes this the absolute minimum. Then I can move on to this point. This point is at 1, 2, 3, 4, 5, 6, 1, 6, 1, 6. That is a maximum, but there are x values that are higher than that. So this is a relative maximum. Then I have this point. You can say that's at 1, 2, 3, -1. So 3, -1. And that is a relative minimum. A point of inflection would be something that looks like this. That would be your point of inflection. This graph does not have one. That is a point of inflection. Okay. All right, so then increasing intervals. The change between increasing and decreasing is happening at these critical points. So the y values here are decreasing until they get to here. So even though we're talking about y values, the intervals that you create or that you write are x intervals. So to start decreasing, my x is at -infinity. Then it decreases to here, and we decided that is -1. Oh, that's, oh, shoot. It's decreasing. I'm writing it for increasing. Dang it. So let's put it down here. -infinity to -1. Sorry about that. That's what's happening there. It's decreasing. So it's decreasing from -infinity to -1. We do not include the -1 because that's when it changes its mind. And now it's going to start increasing. So at -1, it's not increasing or decreasing. But now it's going to increase from here to here. So it's increasing from -1 to 1. I'll put it in the right spot this time. Then we hit another maximum and it starts to decrease. So it starts to decrease at 1 and keeps decreasing till it gets here, which is at 3. Then it turns around and it starts increasing again from 3 to infinity. Couple of things to note for increasing and decreasing. Never have brackets. They're always parentheses, and there's no union either. Okay, these are my two increasing intervals. These are my two decreasing intervals. Okay. All right. Number 9 says determine if the function shown on the graph is continuous. If not, identify the type and location of discontinuity. All right, so I identify continuity by this. I start at the far left side, my smallest x I can get to, and I trace along the function. If I have to pick up my pencil at any point, then it's discontinuous. So it is discontinuous here, okay, because I have to jump from here to here. That is jump discontinuity. Do not just write jump. It is jump discontinuity. And the jump discontinuity, the y jumps from what? 4 to -1, we don't care. It's what you write for here is the x, at x equals -1. So I jump and I'm here. So then I go along and I'm tracing along again, and then all of a sudden I end up here, which is kind of like jumping again, but it's not the same because there's an asymptote. Here there's not an asymptote. I could just snap it back together. Like if I like a little Lego, like I can just like slide it down and snap it in there, that's when it's jump. Here you have an asymptote. So that means that that is infinite discontinuity. Okay. And that is happening here at x equals 2. So then I'm rocking along here and I'm drawing again, and then, oop, I have to pick up my pencil because there's a hole there. So the hole is removable discontinuity. Okay. And that's at x equals 4. Notice all three of them have an x equals type of thing. It is possible to have more than one type at the same time. Obviously, it is possible to have multiple removables in one or multiple infinites, just depending on what's happening. Okay. All right, so then number 10 asks you to describe the end behavior of each graph. Okay, so you have to make sure you know the difference between the end behavior and the domain and range and the increasing and decreasing. Those are all different ways to look at the graph. End behavior is literally what's happening at the end. And it helps a lot if you know what the parent function is you're looking at. This is an exponential. Okay, so do you have any asymptotes? Yes, you do. How many do you have? You only have one. You have a horizontal asymptote right here. There is no vertical asymptote. So to describe the end behavior, we have to say, as x approaches infinity, f of x approaches, right? So as my x values get bigger and bigger and bigger, y is also going to get bigger and bigger and bigger, and it increases all the way to infinity. As x approaches negative infinity, f of x approaches, well, as x approaches negative infinity, this is the only time you get to go left. As x gets bigger, gets smaller, the y values are converging to negative infinity. They're getting really, really close to this asymptote, which is here at -5. So as x approaches negative infinity, the y values are approaching -5. The answers aren't always infinities out there. Okay. All right. Number 11 says use the graph to determine if the relation is symmetrical to the x-axis, y-axis, or the origin, or all three, and confirm your answer algebraically. Okay. So I look at this, we have y-axis symmetry. If I reflect it in the y-axis, it's not going to look the same. If I rotate it, it's not. So my axis of symmetry is here. We have x-axis symmetry. It has x-axis symmetry because for every one of these points, this point exists. Notice your x value stays the same. It's the y value that's changing. So to verify this, you replace y with negative y. So this is negative y squared minus x equals 4. So negative y squared is y squared minus x equals 4. And now this looks the same as this does. I have just verified that when I substitute in a negative y, I get the same, it's not a function, but the same relation back. Okay, and this is not a function because it fails that vertical line test. Right? All right, number 12. Determine if the function is even, odd, or neither. If even or odd, describe the degree. So if in order to do that, this really should say f of x. So I have to find f of negative x, and that's equal to negative absolute value of negative x plus 3. So notice I wrote this down. You have to write f of negative x and substitute it in. Now I can simplify. That's equal to negative absolute value of negative x plus 3. Well, the absolute value of negative x is just x. That's equal to negative absolute value of x plus 3. Now that I have simplified it, this looks the same as this does right here, which means this equals f of x. I have to make that statement also, because you're saying f of negative x equals f of x through this trail of your process. Since that happens, that means that it is even and it is symmetric with respect to the y-axis, since it is even. Okay. Alrighty, number 13. It says find the average rate of change of the function on the given interval. So it gives me this interval. So I need to find f of 4 and I need to find f of 9. Okay. So f of 4 equals 4 squared plus 3 over 4 minus 2. So it's going to be 16 plus 3 over 2, which is going to give me 19 over 2. Then I need to find, so this is 19 over 2. Then I need to find f of 9, which is equal to 9 squared plus 3 over 9 minus 2. So that's going to be 81 plus 3 is 84 divided by 7. And then does 84 divide evenly by 7? Well, 7 goes into 8 once with 1 left over, and that gives me 14. 7 goes into 14 twice, so yes, it does. 7 goes into 8 once with 1 left over. 7 goes into 14 twice. So this is equal to 12. So now that I have those pieces, now I have to find this. The slope of my secant line is f of 9 minus f of 4 over 9 minus 4. So f of 9 is 12 minus 19 over 2 over 5. So probably easiest to get a common denominator here. So 12 with your common denominator of 2 is going to be 24 over 2. So 24 minus 19, well 24 minus 10 is 14, minus 9 gives me 5. So it would be 5 over 2 over 5. And remember that this here is the same as 5 halves times 1 over 5. My 5's cancel out, and my answer is 1/2. That is the slope of my secant line. Please notice that at no time did I make 19 over 2 into a decimal. These basic fraction skills are hugely important for you. Don't let this be a roadblock to you understanding the pre-cal behind it, because the pre-cal is really just the Algebra 1 with some different words. Okay. All right, so let's look at 14. It says the monthly rainfall in Seattle is represented by the function, sorry, board's being weird. By the function, and there's your function, where x represents the month and f of x represents the rainfall. Find the average rate of change from May to October. Okay, so there were some questions about what do I do for my interval? Like, do I start with 1? Do I start with 0? Do I start with 5? Because May's the 5th month. So I want you to think about this. When you get stuck on things like that, you got to ask yourself, like, what makes sense? All right? So the monthly rainfall is depicted by this equation, which if you Google it, it's actually not that equation because I adjusted it so the numbers will be better. But either way, it's kind of close. So where x represents the month and f of x represents the rainfall. So that means that I can plug in any number and get the rainfall for that month. So my numbers can't change. From May to October, it's a 5 months there, so it's not from 1 to 5, because then it would be the same as from January to May, and that doesn't make any sense. So May is the 5th month, October is the 10th month, so my interval is 5 to 10. So that means I have to find f of 5, and that's equal to 0.15 times 5 squared minus 2 times 5 plus 7.25. Now these are decimals, so in this case I'm going to need to use decimals. And let's just do this a piece at a time. 0.15 times 25, okay, minus 10 plus 3.25. Okay, so we can do a couple of different things. You can find 10% of 25 and 5% of 25 and add them together. So by that, 10% of 15% is 10% and 5% added together. 10% of 250, I'm sorry, of 25 is 250 because I'd move the decimal over. So that percent is 2.5. Half of that, well, half of $2.50 is $1.25, so that would give me 1.25. So then that means that right there gives me, why did I write 3? Okay, I'm sorry. Let me back up some. I just looked over there and realized that that makes no sense. You're probably wondering that yourself. Let me fix that. Okay, so I think maybe this was on my brain. So this gives me 375. See how I didn't even multiply with the decimals? Nothing. Okay. You can do the same sort of thing by kind of ignoring the decimals for a second, because if you just multiply 15 times 25, then you can get your number and then move the decimal place over twice. So if I do 10 times 25, that's 250, and I do 5 times 25 is 125, so that gives me 375, and then I have to take into account these decimals here, and look, I get the same thing. So whatever works for you, but notice none of it had like crazy scratch work all over the place. You may not even need to write anything down. Personally, I need to jot things down every now and then, or I'm going to lose the number in my head, but see how I did the percentage thing and think about what's going on with that? All right, that helps you when you're trying to figure out sales and stuff too. You know you're just going to ring up right at the checkout. So this, either way, is 3.75. And then negative 10 and a positive 725, I'll go ahead and combine those. 375 there. Okay, that negative 10, first of all, I'm going to subtract and take the sign of larger. I know it's going to be negative something. So 10 minus 7 is 3. And then take off another 0.25 is going to be 2.75. And then 3.75 minus 2.75 is 1. And that is f of 5. So I found that part. Now I need to find f of 10. That's equal to 0.15 times 10 squared minus 2 times 10 plus 7.25. So that is 0.15, so 10 squared is 100, minus 20 plus 7.25. I wrote it down right this time. So if I look at this, I just want 15% of 100. Well, hopefully you would just know what that is, but if you don't, 10% of 100 is 10. 5% is half of that is 5 is 15, because 15% of 100 is 15. Or if I multiply, I get 1,500, and you move it over 20, you get 15. And then negative 20, positive 7.25 is going to be a negative something. So 20 minus 7 is 13, minus another 0.25 is going to be 12.75. So then when I combine these two, right, I'm going to subtract, and I'm going to take the sign of the larger one, which means it's positive. So 15 minus 12 is 3. Take another 0.75 off, and you get 2.25. And that is f of 10. Okay, so I've got those. Got my pieces. So now I put it all together. And I need to find the slope of the secant line. That is f of 10 minus f of 5 over 10 minus 5. So f of 10 is 2.25 minus f of 5, which is 1, over the 10 minus 5, which is 5. So 2.25 minus 1 is 1.25 divided by 5. Well, if you have $1.25 and you want to break it up into 5 groups, that gives you 5 quarters, so it's 0.25. Okay, and then that's my number, but it says find the average rate of change from May to October. And we've got X represents the month, F of X represents the rainfall. So it's 0.25, the rainfall in what? In inches. Yeah, it doesn't even say that, does it? Dang it. Okay, so 0.25, it's inches per month. I'll make sure the test one doesn't have, I don't know what happened to my inches. It's inches per month. And there you go. I will be here before school during nap time if I have you in the afternoon, but make sure you get this review done and that you understand it. Look over your homework and your notes and everything and be prepared for this test.